Hello everyone, I am Vipul Goyal. Welcome you all to the Pi Scholastics. Today we are going to discussing the topic differentiability. Fearful? Don't worry. We will discuss very basic. Then we will rise the level as you comfortable with the topic differentiability. Before discussing the differentiability, you have also learned derivative in previous videos, है ना? So what is differentiability? So when we will say the some function is differentiable, so let's look. We say some function f of x is differentiable at x is equal to a if derivative of fx exists at x is equal to a. So what does derivative exist at x is equal to a? So first look at the what is the derivative at x is equal to a. So derivative of fx at x is equal to a. How we will define the derivative? Tell me. Hurry up. We will define the derivative as limit x approaches to a f of x minus f of a upon में x minus a. Remember? I forgot. Okay, no issue. So remember that we will also define the derivative in some another form. How? Or we can define this is in limit h approaches to 0 f of a plus h minus f of a upon h. How we can define this and this? If we define derivative as that and derivative as this, means these both will be equal. And how they are equal? Notes look like different. Looks like different, na? So let's have a look. In this expression, replace x by a plus h. We can do that. So look what will happen. Limit when we replace x by a plus h, f of a plus h minus f of a upon x minus a, we replace x by a plus h minus a. A and a will cancel out each other, and here limit we cannot write limit x approaches to a, na, because we don't have inside this function limit as x any variable. What is the variable here? Variable here is h, so we have to write limit in h. So look, whenever x approaches to a, where will h have to go? H will have to go to 0. As x approaches to a, this implies h must approaches to 0. So what we got here is limit h approaches to 0 f of limit h approaches to 0 f of a plus h minus f of a upon a and a cancel out, but we remain with h. Got it? This and these expressions look like same now. So from this expression only we got this expression by substituting x as a plus h. So these are the same things. We discussed this earlier also. Okay. Okay. Let's move further. Forgot all this. So we are discussing differentiability. So when function is differentiable, when derivative of that function exists at that point. What does derivative existence means? Look, Derivative consists as a derivative we defined in a form of a limit function. And do limit always exists? No, limits doesn't exist always. Don't see me like this. We discuss this in limits. Okay. So look. Can you tell me limit x approaches to 0 1 by x? What this is? Sir, infinity. First question we discussed in limit. Remember. So what this limit is? Limit x approaches to negative 1 by x. What we got? Minus infinity. Limit x approaches to positive 0 1 by x. What we got? Infinity. These limits are not equal. This is left hand limit. This is right hand limit. If left hand limit or the right hand limit are not equal, what we will say? This limit does not exist. Okay. So when we will say the derivative of function at x is equal to a exists, when this limit exists. And when will this limit exist? When left hand limit and right hand limit both exists finitely and both are equal. Both exist finitely and both are equal. So instead of this, what we can write here, the definition as another definition as, or we say fx is differentiable at x is equal to a if both left hand derivative and right hand derivative exists finitely and both are equal. So now you are confusing about what this is, sir. LHD and RHD, left hand derivative and right hand derivative. What are left hand derivative and right hand derivative, sir? We don't know. So let's have a look. Limit h approaches to 0, f of a minus h minus f of a upon minus h. This we defined as left hand derivative, and limit h approaches to 0, f of a plus h minus f of a upon h. This we defined as right hand derivative. If both left and right hand derivative are exist finitely and are equal, then what we will say, the function is differentiable at x is equal to a. Otherwise what we will say? We will say the function is not differentiable at x is equal to a in all other cases. Okay, got it? Do you have any doubt? Okay, maybe some student have doubt, sir, how we will get this f of a minus h and minus h. Matlab, here we don't have anything like this, na? So let's have look. Here we both side we defined h is approaching from positive side. Look, in left hand derivative h must be approaches from negative side, na? Look, if h is approaching from negative side, what does that mean? It means that a is approaching from negative side, that we are approaching a from negative side or the left side of the number line, है ना? So when we approach a from left side of number line, what does that mean? That how we can write that as an a minus h also, na? Because the number is lesser than a. Okay, got it? That's how we here got a minus h. Nothing, we just replaced h by minus h. A minus h and minus h. Okay, got it? And how we are writing here h? Because minus h approaches to 0 from negative side and h approaches 0 from positive side. That's why here we replace it. Okay, got it? Okay, let's have a look for one example to understand it better. Do you have written these? Okay, we are not rubbing that for the understanding purpose. So we are looking at an example of f of x is equal to sin x. We want to check that whether sin x is continuous at not continuous at differentiable at x is equal to 0 or not. Is fx equal to sin x is differentiable at x is equal to 0 or no? So first what we will evaluate? Left hand derivative. What is left hand derivative? Limit h approaches to 0 f of f. What is here? Sine of a plus h. What is a here? A is 0 plus h or 0 minus h. Remember, I am checking you. Minus sine 0 upon minus h. What we will get here is limit h approaches to 0. Sine of 0 minus h is sine of minus h minus sine 0, that is 0, make no difference, upon minus h. What is this limit? We have derived this limit. Okay, forgot, no worry. Limit h approaches to 0. What we can write sine of minus h as minus sine h upon minus h. Minus and minus both get cancelled, and what is this limit? Is equal to 1. Got it? What is right hand derivative? Right hand derivative is limit h approaches to 0 sine of 0 plus h minus sine 0 upon में h. So what we got here is limit h approaches to 0. Sine of 0 plus h is sine h minus sine 0 minus 0, make no difference, upon h, and this limit come out to be 1. So here both left hand right hand derivative exist finitely and both are equal. So what we will say? We will say that fx is differentiable at x is equal to 0, or sin x is differentiable at x is equal to 0. Okay, got it? Okay, we will see multiple examples in next lecture. Okay, got it? So that's all for today. Thank you.